So example number 64, a current I is equals to 25 sin 100 pi t milliamperes in an electric circuit. Determine using integral calculus its mean and root mean square over the range t is equals to 0 to t is equals to 10. So they want you to determine the mean and the root mean square of the current I, isn't it? Are we together? So the first thing you know, how do we get the mean? The mean value, isn't it? So we say the mean value is given by, you integrate 1 over b minus a, then you integrate from a to b of f of x dx, isn't it? But here you can see I is a function of t, isn't it? Meaning now we are talking about f of t dt, because it's supposed to be f of x dx when I is a function of x, isn't it? Are we together? But here I is a function of time, it's a function of t, so we are integrating f of t dt, meaning the limit a to b are limits of t. Are you seeing that? The limits a to b are limits of, and you'll be told t is equals to 0 to t is equals to 10, meaning they are telling you a is equals to 0 and b is equals to 10, isn't it? Are we together? This interval of t, you've been given from 0 to 10, meaning you can clearly see your a is 0, the lower limit, your b is 10, the upper limit. Then you are integrating the function f of t dt, because current I is a function of t, isn't it? Are we together? So if you look at this, you now start, what is the mean? The mean is 1 over b minus a, 10 minus 0, isn't it? So that is 10 minus 0. You get 10, isn't it? Then you are integrating from a to b, from 0 to 10, isn't it? Then f of t, you've been told it is 25. It is 25 sin 100 pi t, isn't it? Then you integrate that with respect to t. Are we together? See, when you are integrating, you factorize out the constant, isn't it? Are we together? See, this 25 is a constant, you can factorize out. Well, you can just leave it there, there's no big deal, isn't it? So out here we have 1 over 10 into, if you integrate 25 is a constant start, if you integrate sine, what do you get? Let us maybe factorize outside here. So we have 25 over 10, 25 is a constant, okay? So if you factorize 25 outside, you remain with 25 over 10 into, you remain with sine 100 pi t, isn't it? If you differentiate, if you integrate sine, you get negative cos, meaning we are going to get negative cos 100 pi t. Then we divide by the derivative of the inner function, which must be a constant, isn't it? So what is the constant of the inner function there? 100 pi. Because if you differentiate 100 pi t, when you differentiate t, you remain with 100 pi, isn't it? So the constant there is 100 pi. Are we together? Yes, so the constant here is 100 pi, sine 100 pi t. Are we together? So then you put the limits of integration from 0 to 10. Is that one okay? Is that okay? So what do we have? Remove these constants outside. 25 divided by 10 times 100 is, see outside you have 25 over 1000 pi, isn't it? See 10 times 100 pi is 1000 pi. So you have 25 over 1000 pi. Then you remove the negative outside, it becomes there, isn't it? So what do you remain with inside? Cos 100 pi t from the interval 0 to 10, meaning we remove all the constant outside. The constant is negative 1 over 100 pi. If you factor this outside, you get negative 25 over 1000 pi. So what is the simplest form there? What is 25 over 1000? You get negative 1 over, what is 25 over 1000? 40. So it is negative 1 over 40 pi. Then inside we have upper limit minus lower. So you see, when t is 10, what do you get? It is cos 1000 pi. What is cos 1000 pi in the calculator? The calculator must be set in pi radians, must be in R. Are you seeing that? If you use D, calculator will see that as degrees and you get a wrong answer. Are we together? The calculator must be in R because we are dealing with pi radians, okay? So what is cos 1000 pi? That is our circulating 1, isn't it? You get 1 must be in pi radians, that is 1. Then what is cos 0? Because when t is 0, you get cos 0, isn't it? What is cos 0? Cos 0 is 1. Then there's a problem. What is cos 1000 pi? 100 pi, yes. 1000. See, when t is 10, see 10 times 100 pi is 1000 pi. What is cos 1000 pi?
1.
Positive 1.
Yes.
Then what is cos 0? Also 1.
Yeah.
So what do you get there? So you get the mean value to be 0. So this is 1 minus 1. That is 0. 0 times anything is what? It's 0. Are we together there? You have cos 1000 pi is 1, cos 0 is 1. That is, mean value is 0. Are we together? So can we now go to the root mean? The root mean square value. Are we together? The root mean square value. So the root mean square value, what did we say? When you're looking for the root mean square, the standard deviation, what do? You square the mean, you square f of t first. Then after squaring, now that is mean square, because you take that formula of mean, isn't it? That is now mean square, then you find the square root. So that is root mean square. Are we together? So if you substitute here, what do you have? You have square root of 1 over b minus a, 1 over 10, isn't it? Then you integrating from a to b, then 25 sine 100 by t. The whole of that is f of t. But it is squared in root mean square, isn't it? It is squared, then dt. Are we together? So start simplifying. We cannot integrate sine when it is squared, isn't it? So what do we have there? We have square root of 1 over 10. Oh, I didn't substitute the value of a and b. This is 0 to 10. A is 0, b is 10, isn't it? So that is 1 over 10. Then you are integrating from 0 to 10. Then what is 25 squared? Because that square is for everything inside the bracket, isn't it? 25 squared is 625. Then sine 100 pi t squared is what? Is sine squared 100 pi dt, isn't it? What did we say? You cannot integrate sine when it is squared, isn't it? Are we together? You cannot integrate sine when it is squared. So you use trigonometry to expand it, isn't it? You use trigonometry to expand it. So you can come down here in the rough work, we say, if you have sine 2 theta, that is a double angle, isn't it? Sine 2 theta is supposed to be 2 sine. If you expand it out, you get 2 sine theta cos theta. Still, you will not integrate. Meaning it will still give you a long process of going to factor formulas, product identities, isn't it? So you use cos 2 theta, isn't it? Cos 2 theta is what? Is cos squared theta minus squared theta, isn't it? Are we together? Then you know what is cos squared theta according to Pythagorean identity. It is 1 minus sine squared theta. Is cos squared theta. When you have cos squared theta plus sine squared theta is equals to 1. When you take sine squared theta to the other side, meaning cos squared theta is always 1 minus sine squared theta in Pythagorean identity, isn't it? So we have that. Then it is minus sine squared theta. So if you open this bracket, what do you have? 1 minus negative sine squared theta minus sine squared theta, you have negative 2, isn't it? See, you are now bringing, if you bring negative 2 sine squared theta, remember this side we have cos 2 theta, isn't it? So if you bring it this side, what do you have? 2 sine squared theta is equals to 1 minus cos 2 theta, isn't it? Are we together? Isn't it? Yes. 2 sine squared theta is 1 minus cos 2 theta. Because you have cos 2 theta is 1 minus 2 sine squared theta. So it means when you bring 2 sine squared theta, the other side it becomes positive. You take cos 2 theta, the other side it becomes negative, isn't it? Are we together? So if you remove these two, so you divide both sides of the equation by 2. Isn't it? So this implies that sine squared theta is a half minus a half cos 2 theta. Meaning you divide all through by 2. You get a half minus a half cos 2. Are we together? But what do we have? We have what sine squared 100 pi t. Meaning this theta, where there is theta, you put 100 pi. Isn't it? Where you have your theta here, you put 100 pi t. So if you put 100 pi t there, you get what? You get sine squared 100 pi t is equals to a half minus a half cos 200 pi t. Because 2 times theta, 2 times 100 pi t. We are substituting. The whole of this is theta, sine squared theta. Meaning where this theta, you put 100 pi t. Isn't it? Are we together? Yes. So are you seeing you have found an expression of sine squared 100 pi t, meaning where you have sine squared 100 pi t in that problem, you put this, isn't it? Is that okay? Yes. Are we together? Yes. Yeah. So can we substitute that? Here we now have the square root of, this is 625 over 10, isn't it? This is 625 over 10. If you factorize the constant outside, isn't it? 625 over 10, then we are integrating from 0 to 100, meaning inside, after factorizing this outside, inside we are only made with sin squared 100 pi t, isn't it? Which we found to be a half minus a half cos 200 pi t, then we are integrating the whole of that with respect to dt, which is there, isn't it? So we are done with all this rough work. We can now proceed with what we were doing. All that was rough work to tell us what is equivalent to times sine squared, isn't it? So sine squared 100 pi t is the same as a half minus a half cos 200 pi t. See, this a half is a common factor. You can factorize it outside, isn't it? Are you seeing that? Yes. So if you factorize that half outside, it becomes 625 over 20, isn't it? Then inside you remain with, you are integrating from 0 to 10, 1 minus cos 200 pi t with respect to, are we together? Are we together? Good. So can you start doing that? Integrate. Now start by integrating. We have square root of, what is 625 divided by 20? 625 divided by 20? 31.25, isn't it? Then inside, when you integrate 1 with respect to t, so you remain with the t. Yes. Because 1 is like t raised to power 0. If you integrate t raised to power 0, you get t raised to power 1 over 1, which is just t, isn't it? Yes. Are we together? Then it is minus. When you integrate cos, you get positive sine. So it means we have sine 200 pi t, then you divide by the derivative of the inner function, which is the constant of the inner function, 200 pi, isn't it? You have 200 pi t. So if you differentiate 200 pi t, you get 200 pi. That derivative of the inner function must be a constant, isn't it? Are we together? Then after that, what do? So you put your limits. Your limits is from 0 to 10, isn't it? Are we together? So what do we have? We have square root of 31.25. Then inside, can you start getting upper limit minus lower limit? Upper limit minus lower limit. So you start. When t is 10, where is t you put 10? It is going to be 10 minus sine 2000 pi, isn't it? Sine 2000 pi is 200. Remember, t is 10. So if you bring 10 here, see 200 pi times 10. See, that is 2000 pi, isn't it? So what is sine 2000 pi? See 0. Because that is circulating, sine pi is 0, meaning sine a multiple of that will be 0, isn't it? Sine 2000 pi is 0. So it is 10 minus 0, meaning the upper limit is 10 because t is 10 minus 0. So you substituted for the upper limit, you are done. Then you substitute for the lower limit when it is 0. This will be 0 minus sine 0 is 0, over that is 0. So 0 minus 0 is 0, meaning the lower limit is, but you just use a calculator, isn't it? To get it. Are we together? It is calculator you are using. When you are substituting the upper limit 10, so you put 10 where t is. Yeah. So you are now going to have 10 minus sine 2000 pi. But we found sine 2000 pi is 0. So it is 10 minus 0. You substituted the upper limit is 10. So you are done with the upper limit. Yeah. You go to the upper limit 0. You put 0 where t is. Isn't it? So there is going to be 0 minus sine 0. Sine 0 is 0. So it is 0 minus 0. You get the lower limit to be 0. So it is upper limit minus lower limit. Are we together?
Yes.
Good. So 10 minus 0 is 10. Then times the constant which is outside, you have the square root of 312 point. Because 10 minus 0 is 10. 10 times 31.25, so that is 312.5.
Yeah.
Yes.
So what is the square root of 312.5?
17.68.
You have 17.6? 17.68. So 17.68 is the root mean square value. Are we together? That is the root mean square value. You just move stepwise in that order. Here you are just substituting. You are just substituting with the calculator, isn't it? When I substitute the upper limit, what do I get? When I substitute the lower limit, what do I get? Good. So that is how to deal with such kind of problem.